Um, I'll do 4 hours of C++. I mean, why not? I got T today. I didn't know I got T today. Pretty sick. I think what I will do from now on is I may change to T. I may change to tea. I may actually change to tea because usually I drink coffee. Oh man. I mean, you can drink coffee. I'm not saying you can't, but you know, kind of gets a bit too. That shit. I'm drinking coffee. Like you don't get that good feel. Like you don't get that good omen. Boom, 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 boom. Let's learn four of those step by step. I got this Arab perfume. Let's do step by step. Let's go step by step. Dude, my fucking I don't know, charger doesn't work. I got this. Where's my charger? Actually, fun fact, where's my charger? Oh, I need to buy. Yeah, I need to buy a new um charger. So the most important equation on these pages, the book gives summation of F is equal to ma. This is where everything begins. So not the Kalman filtering, not the AI, not the MPC, not the adaptive guidance. Everything starts here. So the missile is flying and many forces will act on it. So you can have the gravity, you can have the aerodynamic lift, you can have the drag force, you can have the wind disturbance. And eventually, because all of them will be continuous, like they won't be constant, obviously. So you can have float of thrust, float of gravity. Are people watching? You can have float of thrust, float of gravity, float of lift, and float of drag. So everything will be in float. Everything will be in float value. I don't think people will watch live now. You can have float of total force. So total force will be thrust plus, minus drag plus lift minus gravity. Right. So eventually your code will have float of thrust, float of drag, float of lift, float of gravity, and so then float of total force. Please let's try one more time. Let me. So we're going to have float of thrust, float of drag, float of lift, float of gravity. And so then float of total force. So therefore total force would be thrust minus drag plus lift minus gravity. And Newton says the acceleration will be summation of F, which is the force, divided by mass. So because adaptive guidance focuses on position, velocity, orientation. So how would we? Oh shit! It is hot. Why did I? How would we code this part like section by section? How would we? How would we program it section by section? My iPad charger doesn't work, sadly, and I'm trying to understand without writing anything. Okay, so where am I? How fast am I moving? Which direction am I pointing? So you need a position, you need a velocity, you need an acceleration, which corresponds to XYZ, UVW, roll, pitch, yaw, matrix. The flight computer itself doesn't magically know anything because you must measure every one of those, right? You need to measure the angle of each, you need to measure the velocity of each, you need to measure the position of each. And so sensors like GPS or IME or gyroscope, these will measure the current position, the current velocity, the current angular rate. And so the coordinate system, the book spans, okay, we got the Earth frame, body frame, rotation matrix. Because sensors measure things in different coordinate systems, the computer must also convert them into one common frame. All right, let's begin the programming. So let's begin programming, section by section. Let's start. I've done this. Actually, I've done all those. So I have I have done all those. Oh, did I get the wrong snapshot? Oh shit. I got the wrong one. No wonder. No wonder. I got the wrong one. Then probably there is something wrong with the cable. How to know? How to know if there is something wrong with your cable or iPad? No, it's now the thing is I have a lightning cable which only and lightning cable, yeah. And I have only one device that supports lightning cable. I mean, it's pretty tidy anyways. Not sure. Okay, I'm gonna leave like this for the entire duration of my study. I leave it like this. See if that charges. If it does, then good. If it doesn't, then sorry to inform you, but my iPad is damaged. I don't know why would my iPad be damaged, but it seems like my iPad is damaged. Anyways, um, which is pretty sad because this iPad is my life. I have all the notes here. I mean, I have copy of my books, but I have my notes here. I have my. I mean, this iPad was the reason why I got into the dean's list, right? I mean, I didn't. I saved so much money on uh, purchasing from books, from notes, and all that stuff. So I think it's the problem with cable. Cable, like it's all the way at the ground. iPad, I don't even touch as much. I mean, iPad I touch, but I don't know why would iPad be damaged. Okay, this is the entirety of 2.2, I think. Yes, this is the entirety of 2.2. All right, let's begin one image at a time. Let's begin one image at a time, and then we begin the programming for our startup. I have an iPhone 15, so it doesn't, so lightning cable doesn't work. Yeah. So what is this section doing? So the entire page is trying to answer one question. What assumptions are we making before we build the missile equations? So before deriving any equations, engineers will simplify reality. So the book says rigid body. This means the missile bends? No. Missile stretches? No. Missile changes shape? No. It is rigid. So assumption one is a rigid body always. So that'll always be your first assumption, rigid body. So this means the missile bends, missile will not bend, the missile will not stretch, the missile will not change the shape. And this entire missile is one object then, because it's a rigid object. Even if you have so many other things that may or may not create a change, but because it on the exterior it doesn't change, it doesn't stretch. So this entire thing is a unit. So imagine a real missile. So a real missile will have vibrations because obviously everything is continuous. So it is going to vibrate. The fins will flex a lot because when you keep flying, it's not going to stay straight. Wind also plays a role, right? So it's going to bend a lot. The body can bend. The fuel can slosh. Fuel can slosh, as in, let's say, for example, if you were to control the missile, and sometimes like if because what people think is like if you operate a missile, they it'll be like it's going to obviously create a lot of thrust, but at the same time it's going to stay there. No, it doesn't stay there. So it's going to move around inside that container, obviously. And if we included all of that, so you're going to have different equations. So you're going to have an equation for the nose, you're going to have an equation for the fins, you can have an equation for the body. In fact, you're going to have equation for every single component that creates a change based on the uncertainty. Long story short, instead we're going to treat the missile as one solid object, because then if it was the case, in reality we're going to include that, but doesn't mean we're going to go through thousands, because all those changes are occurring inside the missile. Like it's the entire missile that's changing. So we're going to do continuous in correlation to the missile, not in correlation to the noise. Even if I were to say that only noise is changing, even though this is impossible, we would still say that the missile is changing, because at the end of the day, all those missile, all those fins, all those body, all those fuel, whatever's changing is within the rocket or inside the rocket. So, I mean, naturally, you're going to say that the missile is changing. Like the missile position is changing and the missile wind thrust is changing. So you're going to say vector's position, vector's velocity, vector's altitude. Not altitude, altitude. So one position, one velocity, one altitude for the entire missile. So not nose position, not the fin position, not the tail position. So these all positions, because if I were to say that find the position of the nose, and then I'm going to say find the position of the fin, the only reason you find out, it's like saying you have a car tire. Find the position of the tire. Obviously, you don't say find the position of the tire, right? Because the only reason tire moves to a specific position because car moved to that specific position. You're gonna say find the position of the car, not find the position of the tire. I mean, what the fuck says that? Are you like a dumbass or what? Uh, so because in my abstract it says the adaptive guidance, you have the state estimation, you got the MPC or whatever. So which means we need to find the current position, the current velocity, the current orientation for one vehicle. So therefore, rigid body assumption is exactly what is needed. And so what the state vector currently does is you're going to have position, you're going to have the velocity, you're going to have the orientation. And immediately after this will come the 6 degrees of freedom, 6 DOF. You can have three transitions, three rotations, XYZ, roll pitch yaw. So these six values will be the heart of the guidance system because the only reason velocity occurs is because you have a change in position, right? People, I know you're going to say that because the key term is degrees of freedom. Velocity is not a degree of freedom because the only way you can actually calculate velocity is by measuring the change in position per unit time because you don't know what the you don't know what the what do you call velocity is if you don't know what the position is. But if you know what the position is, only then you will be able to calculate the velocity, right? Yes, yes, because these three play a crucial role in literally every uncertainty that exists, and they're numerical, so the computer can read them. Is it possible to write this in latex code? Actually, this will be no, whatever you explained for chapter 2.1 and 2.2, combine them. I mean, sorry, yes, combine them and label the chapter 2.1 as chapter 3.1 for my book, and actually, yeah, chapter 3.1 for my book. Yes. What can the name be though? Each chapter will be a section. Yeah, chapter 3.1 from my book. Here. Please just do the, oh God, man, just do it. Just do the latex code. Please, just do the latex code. I just paid for it. I just paid for this stupid OpenAI. Come on, please, just finish the latex code. Finish and do the latex code for chapter 2.1 and chapter 2.2, and label that as chapter 3.1 from my book, using this abstract as explanation. Oh my god, you're making it in text format. I don't want text format. I want latex code. I want latex code, not text format. This is a wrong method. Please. Yes. It's not, it shouldn't be in rendered text. Oh wow. I still have two people watching. So I'm just going to write it in latex code. Wait, what if Valentina is the one teaching you? I mean, watching. Oh my fucking god, I'm scared. I am fucking scared. Imagine. Imagine. It was like, it was. Oh. Well, okay, I need that begin document. I need that. You know, I'm going to study hard and procrastinate less and study so much without procrastination, like as if Valentina is watching, because you never know. Oh, come on, not a fucking render text. I want a latex code. God fucking damn it, man. I don't want a render text. I want a latex code. Fucking latex code. Fucking latex code. And my fucking iPad doesn't work. How fucking gay is that shit, man? Is it the iPad or is it the cable? I'm not sure. I think it's the cable. How much is the cable? I think cable is cheap enough. God, I need this iPad, man. If the iPad is damaged, I don't think the iPad should be damaged. If the cable is damaged, that's understandable because the cable was on the ground this entire time. I have like so many wires in the ground. But if it's the iPad that's damaged, I'm fucked. I mean, doesn't mean I cannot buy. I can't buy another one, but I have everything I need here. So again, this is not chapter one. This should be chapter three. This should be chapter three. Be chapter three, not chapter one. Okay, can you? Oh my god, shit! Can you fucking fix it, please? Can you fucking fix it instead of chapter one? Can you fucking fix it? Can you just shut the fuck up and fix it for me, man? And fix it for me. I know what he said. He said that because you don't have a previous chapter, so that's why it's going to automatically count it as chapter one. Can you like put a star? Like, oh no, you can't. You know what? Fuck it. I don't even have time to argue. All right, so coordinate system. So during the ascent, the rockets of missiles, the rapid variations in velocity and aerodynamic loads causes a small missile mismatch such as winds or gusts, thrust variations, air density, whatever. The missile motion is described using multiple coordinate systems. So we're going to have the initial frame, the Earth center frame, Earth surface frame, and body fixed frame. The position is vector at x, y, and z, and the velocity is at u, v, and w. And so v of m would be u of I plus v of j plus, I mean, pretty easy, right? Velocity vector. So what you do is like, you have like u, v, w, and then you're going to have I, j, k. So I, j, k will be in 3 by 1 format because obviously it's I, j, k, and u, v, and w would be in column vector, column, because obviously it's a vector, right? And though it's not only a vector, specifically it's a state vector. So in a state vector, I mean, you can represent them in the format of like u, u, v, w, but it's not really accurate because if we actually programming that, and if you put that in the sensor, in some cases, like it may presume that you have three matrices It's actually going to output values based on three state vectors. Sorry, three state vectors. So it's going to actually output based on, oh, okay, I have three state vectors. Again, you don't have three state vectors. Nobody has three state vectors, but the sensor will actually presume that's a three state vector. But again, this is 6 degrees of freedom. So we're going to consider that the velocity having 3 degrees, so XYZ, and the angle, the orientation, or what you call the attitude, you're going to have um, theta, phi, and psi. So they have it transposed. Calm down. They have it transposed. Don't worry about it. What is PQR though? Oh, that's the weight. That's the weight. Oh no, angular velo. Oh, not W. It's omega. It's omega. It's omega. So PQR, P is the angular velocity in correlation to um, the pitch angle. Not the not the pitch angle. Sorry, the rotational angle. Q is the angular velocity in correlation to the side slip angle. And actually, which one is P is the pitch angle? I have a question. I don't care. P is the pitch angle. Is the pitch angle that goes up and down. Q is the pitch angle is there. It's the side slip angle that goes left and right, and R is the yaw rotational angle. I mean, pitch like P. These are the velocities. These are the velocities. Are the velocities? Velocities. Angular velocity. My bad. My bad. I don't want to erase. I'm too tired. Roll angle is left wing up, right wing down. But we don't have wings in rockets, though. We don't have rockets. We don't have wings in rockets. We have fins. There you go. Rotational angle. So for a missile, we will consider it pitch angle, side slip angle, yaw rotational angle. Oh, oh, angular. Fuck's sake, man. Angular velocity. Okay, 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 okay. Angular rates. Okay. All right. We coded that actually. So here. So definition for this structure. So we can have the positions for x, y, z. So there's the position, and we also got the velocity actually. Um, I can see that we made a mistake, right? I can see it. I think so. We made a mistake. Let's see. GCC hello main dot c o hello main. Oh, my bad. I need to fuck. Yes, I know I made a spelling mistake, but even then you have to save it. Even then you have to save it. So GCC hello main dot c o hello main hello main. So obviously we get the position, we get the velocity, we get the directional cosine matrix because that's the cosine in correlation to the roll, sine in correlation to the roll, cosine in correlation to the pitch, sine same thing, and then the cosine and sine in correlation to the yaw angle. And so now we're going to have the velocity of our pitch angle of the pitch moment in correlation to u of I plus v of j plus w of k. Because that That is velocity. Obviously, there is velocity, right? And the only reason we have I, J, and K is because not because, oh, okay, because U exists in I, V exists in J, no, but because the velocity is represented in a state vector. And so if you represent it in a state vector, every single one of those values is a matrix. Even if I were to say U, just U, then I'm going to have UI. I mean, yes, I'm going to have UI plus VJ plus WK, but then who gives a shit about VJ and WK if both of them are zeros, right? And now with the magnitude, obviously you're going to do the square root, you can get your values in whatever, whatnot. The Euler attitude angle. So the Euler vector would be in correlation to uh, theta, phi, so phi, theta, and psi, where the angular velocity is in correlation to, so let's say, for example, if I were to have um, uh, the pitch angle, so if I were to do the pitch angle, then I can say that the angular, what is the angle, the amount of speed or the pitch rate, right? The pitch rate will be P, which in shorter terms, they're going to measure it in meter per second. So omega is more of like, okay, so it's moving 80 meter per second at a 45 degrees angle. So that 80 meter per second is typically the angular velocity. Q is also the velocity. This is in correlation to this. So let's say um, let's say 45 degrees to the left with a velocity of 45 meter per second. So that's, you got your angular velocity for the side slip angle. So that's the pitch, not pitch rate, side slip rate. And the same goes for the rotational rate. So it can also go at a certain speed while rotating. And then rigid body equations of motion, the missile so let's just make it simpler so that people can understand. So if Valentina is watching, Valentina can also understand what's going on. This book will be for everyone, so I'm going to make sure that you understand thoroughly. So can we explain this again? But just let's make it easier so that everyone around the world can understand. Can we make it a little easier? Although the explanation is really good, but let's make it detailed so that everyone can understand. And also correlated with the abstract that I have shown, and also correlated with the abstract. Correlate with this abstract. Yes, I'm gonna sleep. Convert whatever you explained to latex code. Convert whatever you explained into latex code. And let's move to, I hope Valentine is watching. I don't know. Is she? I don't think she's going to watch. I don't think, impossible. Impossible she's going to watch. She's going to stay up. What's the time in Texas now? Yeah, right. She's going to stay awake at 3:17 a.m. And nah, nah, not gonna happen. Not gonna happen. Don't worry about it. Nice try though. Nice try, but nope. If that happens, I swear to God, if that happens, I'm not procrastinating. I cannot procrastinate. The only reason I'm not procrastinating is only because of her. Because you never know. You never know. I'm telling you again, you never know. If she watches, because she hates me. I'll tell you one thing. She hates. Like, there's the definition of hate. So there are three sections of hate. One is hate. One is personal hate. The other one is identity hate. Valentina lives on the fourth one. There is something called Valentina hate. So there is hate. There is personal. Are you guys watching? Are you guys watching? Yeah, yeah, yeah. Keep watching. Keep watching. Keep watching. You guys have hate. You have personal hate. You have identity hate. Then you have Valentina hate. That is unmatched. If she sees my face, I'm done. I'm cooked. The fact that I have to worry that, oh shit, she's watching my stream. She's watching my stream. Oh, she's gonna kill me, man. Anyways, but yeah, I mean, she's a fun person. She's really nice. She's really nice. Yeah, like she made me someone. Like the entire reason why I'm doing this is because of her. Now this fucking iPad doesn't work. Let's do a rigid board. Can we do a the Python program for this? Not Python, sorry. Can we do a C program for this, or the code I copied? The code I copied, is that enough? I don't think. I highly doubt. Yeah. Yeah, there's a lot of maths, a lot of math. All right, I do have the program with me. Anything that I have to modify from here, anything that I have to modify from this code or add from this code, just add it. Anything that I have to modify or add from this code, just add or modify it. Because I just want to move quickly. I am tired. Let's do these two because I'm not only doing this, I also have MATLAB. No, yeah, just write the entire code. Just write the entire code, like in one go. Yeah, 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 just write the entire code. I want to do this section here. Axis and moment nomenclature. It's OX, OY, OZ. Because even I'm trying to understand like what's going on. Sorry if I'm not talking too much. But even I'm trying to understand what's going on. So forward, right wing, downward. You have the roll, you have the pitch, you have the yaw. And so when you have the linear velocity, that is UVW. Angular displacement is God. Let me just try to understand. Man, if only my fucking. You know what? I'm not going to give a fucking excuse. I have books with me. I think either I need to buy a charger or I need to buy a few books. Either or I'm cooked. Yeah, I'm just going to buy. I'm going to buy like 4 books. Okay, I can't find a pen. Just find a pen. Oh, I have 3 pens. Just give me 2 seconds. All right. Um, just copy this code quickly. Let's save it. GCC hello main. Oh, sorry. Hello main.c. Oh, hello main and hello main. Pretty much the same thing. Same thing. I've done this, so it's fine. All right. Let's do these pages. I'm going to buy a few books actually. I'm going to buy a few books from Walmart. I have to. Let's do these four images. Four images step by step. I mean, if I can buy another iPad, that's fine. If the iPad is damaged, I really can't care less. I can buy another one. I'm not even planning. Actually, you know what? Let me see if Samsung is good. I think Samsung is better. Samsung is better. Samsung tablet. Yeah, Samsung's pretty good. I'm not going to buy now because on I got good paycheck. Like I actually got really good paycheck, but I'm gonna wait. I'm gonna wait. I got really good paycheck, really good, like really really good. Like I'm happy with what I got. Obviously, you guys think it's $10,000, $20,000. No, I only work as a researcher because for me, like payment, like how much I get paid, that's never the issue. Because if you want to see what I'm doing, dude, you won't care about how much you get paid. I know people care about payment and stuff like that, and they think that it's kind of like one of those minimum wage job. Fuck no, fuck no. Because I want people to see where I work. This is the first time I'm working. This is the first time I'm working as a researcher. Like I don't mind working for free because it's so good. Like you have to work with photonic lights, then you have to understand how much, like you have to measure this. So let's say, for example, if the photonic light goes on, so it's kind of like transferring, right? The only reason we do this photonic light is because let's say it hits, and then you're gonna get some graph like shoop. You have to measure that, and then you have to compare that with. Okay, I'm getting too complicated. Getting too complicated. Nope. So long story short, if you want to do, if it's kind of like because in quantum computing you mostly work on lights because unlike the classical ones which are like electricity, so you don't use electricity, you use lights because anything related to quantum is on light. And the only reason you use lights is because light can behave both as lights and particles. So it's typically like saying that we have like every particle is going to hit on the other wall, and so we're going to consider that as being transferring something, like transferring anything, transferring data, transferring something. And because we don't have that huge computer, I don't know if you know the infamous quantum computer, right? We don't have that infamous large quantum computer to see that. I think it's in Waterloo University. Waterloo University has one, and so the alternate one is, so like we're gonna have like few glass, like few prisms, and then we're gonna make sure we're gonna hit that. We're gonna have that one green laser light. We're gonna hit that on the prism wall. We're going to get the wavelength. So obviously, we have to measure it quickly because it's going to take 1 second to few milliseconds. You must understand one thing, that only within few milliseconds it's gonna give you a range of date, it's a range of time, like the range of wavelength. And so from that wavelength, you'd have to measure the time it took, what's the graph, what does the graph look like, and stuff like that. Because usually it's not going to stay static. It's actually curved, and the only reason it's curved is because continuous. It's not like discrete. And so, long story short, we have to hit the beams and then quickly measure them, quickly get the ideas and stuff, and then go to your lab and collect as many data as possible because we don't have that huge computer. Because if we want that huge big ass quantum computer, you'd have to typically have like a huge space. Now we do have huge space, but we don't have a space for a fucking quantum computing CPU, right? Or QPU, whatever you call it, QPU, whatever. We don't need the huge computer. We have Qiskit, we have Penny Lane, and again, it's not. It's like the first one, right? I mean, you got the funding. Funding was really good. Like I know on like March, I got my email. I specifically sent this to Valentina that I actually sent this to Valentina that for our research that we actually got good fundings. Like I sent this to Valentina. Valentina never congratulated, but yeah, we got good funding. Really good funding. Really good funding. So I think they funded around like I don't know, 3.1 maybe 3.1 or 3.4 million dollars across all Canadian universities. So funding was really good. The funding was really good, but it's not only physics that works on it. We have like combination of physics is there, maths is there. So typically, like if you want to do maths honors, then you can do that. But then the thesis for that is a bit different as compared to the one in physics. But yeah, I don't think I'm going to do thesis for physics. I don't want to do. I'm moving to maths because physics I'm typically done. So I may do maths honors. But then if they have math for this, the quantum computing one, I'll gladly take it. I would gladly take it. Yeah, today I have. I'm going to go at 9 o'clock. We'll have f is equal to fx of I, fy of j, fz of k, so which tells us about the linear motion. Now the book introduces the rotational equivalent. So we're going to have L is equal to dh of z by dt. We're going to have m is equal to dh of y by dt, and n is equal to dh of z by dt. So the book is saying that the forces cause acceleration and the moment or torque causes rotation. And you already know that F is equal to ma. F is equal to ma from obviously high school physics, Newton's second law, right? We know that F is equal to ma, and the rotational version for rotational force m is equal to I alpha, where m is the torque, I is the moment of inertia, and alpha being the angular acceleration. So long story short, if you have angular velocity, now call that angular velocity the velocity in correlation to the angle like PQ and R. Obviously, you're gonna if you were to derive PQ and R, then you're gonna have alpha, right? So missile has three rotational axes. So you're gonna have body of x of axis, body y axis, body z axis, and the book labels them as L, M, N. If we go back, it's written as LMN. LMN are not angular velocities, but we already have PQ and R. So in our case, the angular velocities will be represented in the form PQR. Actually, I'm going to buy them right now. I don't have to go to Walmart, right? No, I'll go to Walmart. It's fine. It's much cheaper. It's much cheaper, anyways. So you currently have omega, which is PQ and R, which tells us that how fast the missile is rotating, obviously. And the new variables will tell us what is causing the rotation. Yeah, I have omega is equal to PQ and R, LMN. So these, if I write omega is equal to PQR, these will tell us how fast the missile is rotating. So these tells us how fast the missile is rotating. And the new variables LMN, they will tell us what causes the rotation. What causes the rotation? Oh, people are watching or people are not watching? I don't know. Oh, come on. I always have this one view. Who is this one viewer? So suppose the guidance computer commands a fin deflection. So the fin produces an aerodynamic force, and that force creates a torque. So LMNN, right? The fin produces an aerodynamic force, then the force will create a torque. And the torque is what causes this LMN. So torque on the x-axis, torque on the y-axis, torque on the z-axis. And so these torques change the angular velocity. And the angular velocity will then change the rotational angle itself. Right? So it's like a small chain of events. So for example, so suppose the guidance computer commands fin deflection. So suppose guidance computer supports fin deflection. Okay, so we have L, M, N, which is the aerodynamic force. So this creates aerodynamic force. Here I'm going to buy one. I have money, don't worry. I'm just going to buy the books quickly. I'm going to buy 3 books and an Apple charger. Or what page is this? 360. I want a 360 page. I want a 360 page. 360. Okay, let's see if they have a 500 page book. No, I want an. No, they don't. They have a 200 one. 300 pages is good. Oh, is it that cheap? $629. Holy shit. $629 each. Why am I waiting? No, I mean, why am I waiting? Like, why am I, Dollarama has it. Dude, Dollarama's right here. No, man. There are cheaper books, bro. Anyway, so suppose the guidance computes the support for fin deflection. So LMNN, so aerodynamic force. And the force will create a torque. So LMN, right? The fin will create an aerodynamic force because if I were to look at the fin, you can have the wind blowing and then it's going to, right? So it's going to create an aerodynamic force. So force creates, I mean, not force. Actually, yeah, force creates torque. Force, specifically the aerodynamic force, creates a torque. And the torque will change the angular velocity. Torque changes the angular velocity. And the angular velocity will then change the rotational angle. Angular velocity changes the rotational angle. Does it have vector 3 moment? Okay, can you remove all the... Okay, it does. Yes. The roll moment, pitch moment, yaw moment, roll rate, pitch rate, yaw rate. Yes. Yep. I understood. I understood. Can you convert this into latex, by the way? Can you convert this, whatever you explained, into latex code? I'm just going to wait like this. I want to see if that one viewer is actually, is it me or is it someone else actually watching? Imagine if that guy watching is Valentina. Oh, imagine if that guy watching is Valentina. I completely forgot. Although I know very well that Valentina will not watch. Um, here. Yeah, let's continue. Let's move. Let's move. Let's move. Let's go. Windows. Nah.